Good day, people. Today we're going to review Unit 4. So Unit 4 was all about generating equivalent expressions. For the first chapter, we wrote and evaluate algebraic expressions. Adi makes and sells knit scarves. Next week, she will pay a $25 fee for the use of a booth at a craft fair. She will charge $12 for each scarf she sells at the fair. Write an expression to determine Adi's profit for selling S scarves after paying the fee for the use of the booth. So we know that she sold S number of scarves for $12, so we can use 12 S to represent the total amount of money she would make from selling scarves. We knew that she paid $25 for the booth, so we can subtract that cost from the total amount that she made, and we would have gotten her profit. So this would be an expression to represent her profit. The cost to buy P pounds of potatoes at 32 cents per pound and N pounds of onions at 48 cents per pound can be determined by the expression 0.32p plus 0.48n. How much will it cost to buy 4.5 pounds of potatoes and 2.5 pounds of onions? Alright, so we see that they're asking us to find when P equals 4.5 and when N equals 2.5. So we would have 0.32 times 4.5 plus 0.48 times 2.5. That would give us 1.44 plus 1.2, which gives us 2.60. So the total cost would be $2.60. For chapter 2 and chapter 3, we generate equivalent expressions by simplifying expressions. So we're going to simplify these two expressions. So first, simplify each expression below. Alright, so we realize that we're working with different terms, so we have to identify the like terms first. So I'm going to circle this term, all the terms with W. You notice I circle the sign that is before it as well. Circle all the signs, all the terms with W. Now I'm going to box all the terms with Z. Box all the terms with Z. Lastly, I'm going to put a triangle around all the terms that are constants. You notice there's no sign that is left outside of my shapes. Alright, let us rewrite this expression using the commutative property. Alright, so we have negative 8W plus 6W plus negative 4Z plus 9Z plus 2 minus 7. Let us combine the like terms now. So we get negative 2W plus 5Z minus 5. So that would be our final answer. And remember, these three terms are not like terms, so we cannot combine them. We have to leave our answer as it is right here. We could also check our answer by substituting a value for W and Z and do the same in the original expression and see if we get the same value. Alright, let us move to the next question. So in this question, I'm going to circle all the terms that are constants. Alright, that's the only constant right there. Let me put a box around all the terms that has a D. Okay, let me rewrite my expression. So we have negative 6 plus negative 2D plus negative 4D plus 3D. We see that there's nothing to combine the negative 6 is, so we have to put it back. Negative 4 plus negative 2 would give us negative 6. Negative 6 plus 3 would give us negative 3D. So this would be our answer. Remember, we can check our answer by substituting a value for D in both expressions and see if we get the same value for our answer. In chapter 4, we expand the expressions. So we're going to expand these two expressions. We're going to use the area model. So we have 3.5 and we have negative 3n and plus 4. So they gave us the width and they gave us the length. Our job is to find the area. So negative 3.5 times negative 3 gives me negative 10.5. 3.5 times 4, it gives me 14. Alright, so we see that when we expand this expression, our answer would be negative 10 0.5n, don't forget the n, plus 14. Alright, so this would be our answer. Our next question now. Alright, looking at this question, we realize that these two terms are like terms, so we could combine them before we expand. So we have -5, -11 plus 5 over 9x. Now we can go ahead and use our area model. So we have -3/5 outside our parentheses, and we have -11 plus 5 over 9x. -3/5 times -11 gives me -33 over 5. Sorry, positive 33 over 5. And -3/5 times positive 5/9, that would give me -15 over 45x. Alright, so when our answer would be in a simplified form, we know that 5 can go into 33 6 times, so that's 6 3/5 minus, and we know 15 can go into that 3 times 1/3 x. So this would be our simplified answer. In chapter 5, we factored expression, which is basically the opposite of expanding expressions. So for this expression, we're going to factor it. So we're going to use the area model just the same. So first we draw our rectangle, 63a minus 42b. Our job now is to find the GCF, the greatest number that can go into both of these terms. And we can see that that number is 21. So we know the width that is common to both rectangle is 21. 21 into 63a goes 3a. 21 into -42b goes -2b. So in order to factor this expression, we need to write our answer as the product of two expressions. So we have 21 and 3a minus 2b. So there we have factored the expression. To check your answer, you could have multiplied 21 times 3a. You see that we get back 63a. And 21 times -2b, we see that we get back -42b. All right, let me use the area model for this example as well. 81y plus 543. So we need to find a number that is common, the GCF. So let us find the GCF. All right, we see that the GCF would be with 3. All right, so 3 into 81 would give me 27y. 543 divided by 3 would give me 181. And if we check, we see that there's no number that can go in, there's no GCF, or there's no factor that can go into 27 and 81 without leaving a remainder. So we know that 3 was our GCF. So our answer is 3, 27y plus 181. Remember, we can check our answer by multiplying or expanding the parentheses. So 3 times 27y, which would give us 81y. 3 times 181, which would give us 543. For chapter 6 and 7, we add and subtract expressions. So simplify the expression. We have 6x minus 2y minus 5 minus 3 minus 5 plus 9y minus 8x. Okay, so we have to see that there's an invisible one right there. 1 times 6x would give us 6x. 1 times -2y gives us -2y. 1 times -5 gives us -5. 3 times -5 gives us positive 15. 3 times positive 9 will give us -27y. -3 times -8x gives us positive 24x. Now let us identify our like terms. So I'm going to circle all the terms with x. I'm going to box all my terms with y. Remember not to leave out the signs. Please include the signs. And then I'm going to put a triangle around all my terms that are constant. Now I can rewrite this expression combining like terms. So we have 6x plus 24x minus 2y minus 27y minus 5 plus 15. When we combine the like terms, we get 30x minus 29y plus 10. So this would be our answer. Question number 10. Last week, Jean ran 2 fewer than 4m miles. This week, she ran 0.5 mile more than last week. Write and simplify an expression for the total number of miles Jean ran in the 2 weeks. So last week, she ran 2 fewer than 4m, so we know that's 4m minus 2. This week, she ran 0.5 miles more, so we know that's 0.5 plus whatever she ran last week. So this was last week. This week she ran 0.5 miles more than what she did last week. So this was last week and this would be this week. So they want to write a simplified expression for the total number of miles. So since they want a total, we have to add. Alright, let me put my invisible ones. Alright, so we see that 1 times 4m would give me 4m. 1 times negative 2 gives me negative 2. 1 times 4m would give me positive 4m. 1 times negative 2, negative 2. And 1 times 0.5 would give me positive 0.5. Let us identify our like terms. I'm going to box all the terms that are constants. So we get 4m plus 4m minus 2 plus 0.5. When we combine like terms, we see that we get 8m minus 2 will be minus 4 plus 0.5. That gives us minus 3.5. So this would be our answer to represent the total number of miles Jean ran in 2 weeks. And lastly, we analyze equivalent expression. So Al earns $10 per hour. Next month, he will receive a 2% raise in pay per hour. The expression n plus 0.02n is one way to represent Al pay per hour after the raise. Write an equivalent expression that will represent his pay per hour after the raise. Alright, so we have n plus 0.02n. Alright, so this is the expression that we have. They want us to write an equivalent expression. So we could factor this expression. So I'm going to use the error model to factor the expression. So we have n plus 0.02n. We see that n is common to both terms. So we factor out n. N into n goes 1 time. N into 0.02n goes 0.02. We write in this expression as a product of 2 factors. We get n 1 plus 0.02. We could also combine these 2 terms. We see that we get 1.02n. They asked us for 1 equivalent expressions. Here we gave them 1, and here we gave them another 1. So that's 2 equivalent expressions. Next question. A store offers 8% off all items. If G is the original price, write 2 equivalent expressions that represents the final price with the discount. So we know G is the original price, then there's a discount, so we have to subtract 8% of G. So G is the original price, then we have to subtract 8% of whatever G was. Okay, we can rewrite this without the percent, so we can write G minus 0.08G. From there, we could factor the expression. I'm going to use my error model since it's always easier to show. So we have G minus 0.08G, and we see that G is common to both. G into G would go 1 time. G into negative 0.08G gives me negative 0.08. From there, we could rewrite our expression as a product of 2 factors. So we have G 1 minus 0.08. We see that we could combine these 2 terms. 1 minus 0.08 gives me 0.92G. Alright, so they asked us for 2 equivalent expressions. This is 1 right there. That's 2 right there.